Once I was 20 years old, pocket got old. Okay, how to convert this into factor form. Now, let's say that I give you a problem like this, a quartic equation, degree 4, and you need to convert it to factor form. I don't tell you any of the roots, gosh darn it, right? I don't tell you any of the freaking roots. So the question is, well, how in the world are we going to get them? Well, this is great because we have a graphing calculator. And what we can do is, we can plug it in. So I went y equals, and then you can already see I already plugged it in, x to the 4th plus 3x to the 3rd minus 13x squared minus 15x, right? Now, there's a theorem, and you're going to notice this on one of the packets I gave you. I believe it's called the rational root theorem. Okay, I could be wrong. Oh, no, I think it's called the factor theorem. Either or, basically the idea is simple, right? It says, if these are my roots, let's say right here, and right here on this x-axis, right? Let's say that this is 3. Well, what is my y value there? Well, my y value has to be 0, right? Because those are my roots. My roots are my x-intercepts. We're just moving to the left, to the right or to the left. We're not going up or down at all. So our y value is just 0. So what that means is, if I have the graphing calculator, I can plug my equation in and go to the table. And if I find any zeros here, right, well then I know that these numbers are my roots and I can write them down over here. Okay, so let's go ahead and do that, right? So we go to our graphing calculator, we plugged it in, let's graph it. Let's just kind of see how it looks like. So we could tell that there should be 4 roots. There's one there, one there, one there, one there, right? You're probably asking yourself, well, we know all the roots. Let's just write it into factor form. Why do I need to convert it and all that stuff? Well, I understand your point of view, but I just need us to get the practice, because when we go to harder problems, we won't be able to know the exact location of these roots here. All right. So what we do is we hit second, and then we go to table, and we start looking for, well, look, when y value, all right, so my roots I can see is, when my x value is 3, my y value is 0. So one of my roots is going to be 3. We also have, well, 0, 0. So that means 0 is a root. And, oh, negative 1. And negative 5. Okay. So we know negative 5 is, so we know these are my 4 roots. So really, if I wanted to write this into factor form, it would be x minus 3, x plus 1. Oh, sorry, I forgot the 0. X plus 0 or whatever. X plus 1, and then we'd have x plus 5, right? So that should be my final equation, but let's pretend we don't know that. Well, you should know that because it's a way for you to check your work, all right? Now, we only need one of the factors right now, so let's just write it. These are my factors. We know we have x plus 3. We know we have just x. We know we have x plus 1, and we know we have x plus 5. All right? So we can use any of these to use long division on this problem right here. All right? So, I don't know. You decide which one to pick. All right, well, I guess, I don't know. We'll go with just... maybe we'll go with just x, right? Maybe it looks like the easiest one to work with. So let's set up, no, actually, let's use x plus 1. What the heck? I want to use one that's challenging, so that way we go more of the challenging ones together and you can do the easier routes later. So let's go ahead and set that up then. We know one of the factors is x plus 1. We're going to get x to the 4th. Let me just put it up here so I could see it. Plus 3x squared minus 13 to the 3rd power. To the 3rd power minus 13x squared minus 15x. All right. Now, just like before, let's just go ahead. I'm gonna put my line here and we begin like we always do. All right. X times what gives me, well, the first term right there, which is x to the 4th power. Well, that's going to be x to the 3rd. So that means that over here I'm going to have x to the 3rd. Okay, now we just multiply. Well, what's x times x to the 3rd? That's going to be x to the 4th. And then what's 1 times x to the 3rd? That's going to be plus 1x squared. I mean, x to the 3rd. Sorry. Okay, now we put the little line underneath. Now we just subtract these, and we're going to get 0. All right, well, 3x squared minus 1x squared is going to give me 2x squared minus 13x squared minus 15x, right? Because I'm just bringing these down. So I'll go ahead now right over here. X times what gives me this first term, 2x squared? Well, let's write that down here. Well, that has to be... Oh, shoot, I apologize. It should be to the third power. Why do I keep doing that? I'm so silly. Okay, there we go. So x times what gives me 2x to the third power? That comes from this right here. Okay, well, that's got to be, you guessed it, 2x squared. All right, so that means that this next term is going to be plus 2x squared. Okay, so x times 2x squared is going to give me 2x to the third power, and then 1 times 2x squared is going to give me plus 2x squared. Now, we flip the signs on them, and we proceed like we've always done. This is going to be 0, and then negative 13x squared minus 2x squared is going to give me negative 15x squared. We bring this down here, and we're going to get negative 15x. All right, now we just got to ask ourselves, what do we do from here, right? What do we do to finish this problem here? All right, and now we just proceed just like we have always done, which means we're going to write on this corner here, x times what is going to give me, well, this term right here. That's going to be negative 15x squared. Well, of course, that's got to be negative 15x. So minus 15x. Oops, I want to stay with the same color blue because it's nice. That's nice. And we get minus 15x. All right. And now we just do what we've always done, right? Well, what's x times negative 15x squared? So we're going to get negative 15x squared. And then what's 1 times negative 15x? Well, that's going to give me negative 15x. We flip the signs on these, and you'll see that we're just going to get a remainder of 0, which is great. So now let's go ahead and write down below here. Okay, we got x plus 1 times x to the third plus 2x squared minus 15x. Okay? Okay. All right, so now we can use any of these roots up here. All right, and I kind of went through and edited. I realized, if you noticed before, I had x plus 3, right? But that wouldn't really make sense because this is positive 3, so the factor should be x minus 3, right? So in the beginning, I wrote that there. I apologize. We should have an x minus 3 here, right? So we can use any of these roots here, right? We'll go ahead and use this first one here. So we have to basically use long division again on that, right? So we have another factor which we can use. So let's do our x minus 3. And down below, we're going to get x to the third plus 2x squared minus 15x, right? We're going to do this now with this new equation here to reduce this even further. All right, and now we just proceed like we've always done. X times what gives you x to the third power? Well, that's just going to be x squared. So let me just go ahead and scroll down so that's not in the way. So now we're going to get x squared, right? Well, x times x squared is going to give me x to the third power. And then negative 3 times x is squared is going to give me minus 3x squared. Okay. Just like before, we always flip the sign on these. So this is going to become minus positive. All right, hopefully by now this is a little repetitive on the process of how we do this. And we're going to get 0. This is going to give me 5x squared minus 15x. So now I'll go over here and I'll write in this corner. X times what gives you 5x squared? Well, this has to be 5x. So I can go ahead and write, this is going to be plus 5x. And then last but not least, all we do now is just multiply across the way with, well, what's x times 5x? Well, that's going to give me 5x squared. And what's negative 3 times 5x? And that's going to give me minus 15x. All right, and all we do now is we flip the sign on these. 0, remainder 0. So we're done. So we can finally conclude, all right, that we're going to get x plus 1 times x plus 3 times, well, we have this right here, x squared plus 5x plus 5x, right? And we have to finish this problem off. Now, we could use a quadratic formula. We could do a few things to figure this out, right? One thing that might be helpful is I might put a plus 0 in here, right? And that should kind of help you out, right? So if you really think about it, because we should get x plus 1, x plus 3, and we should get 2 factors, right? Well, what two numbers multiply? So if you write 0 up above here, right? What two numbers multiply to give you 0, but add to give you 5? Well, the only way to make that work is when you think about the middle term. That has to be 5 and 0, right? 5 times 0 is 0, and 5 plus 0 is 5. So our equation is going to be x plus 0 and x plus 5. So in other words, this is x plus 1, x plus 3, x, because x plus 0 is just x, and x plus 5. Okay? And that kind of works because we know that that is the 4 roots that we should have gotten, right, when we went to go simplify it, which is great, right?